All right, this is the fifth and final lesson in Unit 3. This is Applications Part 2. And last section I showed you guys 4 different types of story problems, and I'm going to show you just 2 more here in this one. And these are the ones that I feel like maybe we need to focus on a little more strongly. So this is using equations to solve consecutive integer questions and then distance, rate, and time problems. So some classics in here, all right? So first example, it just says, question, the sum of 3 consecutive integers is 657. Can you find the integers? Well, what we know in this problem is, well, there's some language. Sum means addition. 3 consecutive integers, well, integers are counting numbers, positive and negative. So they are counting numbers. Both positive and negative. So like -4, -3, and -2 are 3 consecutive integers. And so are 15, 16, and 17. Those are 3 consecutive integers. Okay? And they can even cross over, like -1, 0, 1. Those are 3 consecutive integers. Oh, we're looking for the 3 that add up to 657. Okay? So what we can do is we can call the first one just n. And the second, let's just make this a little bit better here. Hang on. And we'll go, my first number is just going to be n. Well, then what's the next one going to be? Well, because they're consecutive integers, it's just one more than n. So it's just n plus one more. And then the third one would be just one more than the second. So if you just add another 1 to n plus 1, you get n plus 2, okay? And what I know is that if I add those together, because that's what sum means, they equal 657. So there are 3 n's there, so n plus n plus n is 3n, and 1 plus 2 is 3, and they equal 657, so I'll subtract my 3, get that away from this side. That's 654, and then I'll divide 654 by 3, and I get 218. So my first number is 218, and guess what the next one is? It's 219, and the next one's 220. So those are my 3 consecutive integers right there. They add up to 657. Type them into your calculator, you'll get 657. Okay, so let me explain then a little bit about what we did in this problem. Okay, a little more background for you. So consecutive integers are counting numbers, either positive or negative, and they follow one after the other. You can see there 3, 4, 5, 6, so on and so forth. But there's also consecutive odds, which would be 13, 15, 17. And there's consecutive evens, like -2, 0, 2, 4. And so the thing you need to understand about consecutive odds and consecutive evens is they differ by 2 each time. So 13 to 15 is a jump of 2, and 15 to 17 is a jump of 2. And the mistakes that students make over and over is, for consecutive odds, they want to say n plus 1, n plus 3, n plus 5. You don't need to add an odd to another odd to keep it odd. If you take any odd number and add an even number to it, you get another odd number. Okay? So these differ by 2 as well. You can see that. Just add 2 and you get to the next one. Okay, so consecutive integers differ by 1. And that fact allows us to represent unknown consecutive integers using n, n plus 1, n plus 2. If I need another one, I just go n plus 3, n plus 4. As many representations as I need. Maybe the problem says 5 consecutive integers, okay? Consecutive odds or evens differ by 2. So no matter if they're odds or evens, I can use n plus 2, n plus 4, n plus 6, n plus 8, so on and so forth, to represent those in my equation, okay? So consecutive evens and consecutive odds, I'm using n plus 2, n plus 4. For just consecutive integers, I'm using n plus 1, n plus 2. So these are the things that I want to focus on right here, this and this. I'm going to use those quite frequently, okay? All right, so example 1, the sum of 3 consecutive integers. Well, that just tells me right off the bat what I need. For 3 consecutive integers, I need n plus 1, and n plus 2. And it says the sum, so I'm going to add those 3 things together like this. Is means equals 582. Well, there are 3 n's there. There's a 1 plus a 2. I subtract 3 from both sides. That makes 499, right? No, what am I talking about? Makes 579. Sorry about that, fans. 579 divided by 3. So dividing by 3 on both sides. N comes out to be 193, but we're not finished, right? It says find the 3 consecutive integers. Well, I just go 194 and 195. And there's my answer, okay? You try that one. See if you can get it. All right, hopefully you paused and stopped that. It says 3 consecutive evens. And it says the sum, so I'm going to go n plus 2 plus n plus 4. So there's my 3. I used n plus 2, n plus 4, and I'm summing them, so I added them. And that equals a negative 198. Well, I hope you realize that the answers here are going to be negative, right? N and an n, that makes 3n, but this time 2 plus 4 makes 6. Negative 198. I'll subtract 6 from both sides. 3n equals a negative 204. And then divide that. Make it negative 68. So if you add 2 to that, it goes to less negative. It's negative 66 and negative 64. Okay. So it says find the 3 consecutive integers, and there they are. Hopefully you got that one right. Example 2. Oh, this one gets a little more complicated. The sum of the least and the greatest of 3 consecutive integers. Well, let's write them down. I'm going to use n plus 1, and n plus 2. I'm going to sum the least and the greatest is 60. So the least would be n, and the greatest would be n plus 2 is 60. What are the values of the 3 integers, 29, 30, and 31? Yeah, 29 plus 31 makes 60. So there it is, yeah. So this takes into account a little bit of the, English to math as well. That's why I studied that one first, or gave that one to you guys first, is because a lot of sentences then describe the mathematics you need to write. So sum, we're adding the least and the greatest. So in that list, the least is this one, the greatest is this one. So I added those 2 together. Is means equal. This just tells us what we're doing of 3 consecutive integers. That just tells us to write these down. Okay, so really not part of the equation. All right, you guys try the next one there. Stop the video, start it up again. This is the lengths of 3 sides of a triangle are consecutive odd. So I'm using n plus 2, and n plus 4. So that's what this tells me. What is the length of the longest side if the perimeter is 45? Well, how do you get perimeter? Well, you add up the sides. So I'm going to add all these together. So there are 3 n's and then 6 in constants. Subtract 6. Divide 3. 13. So the lengths of the sides. It says, what's the length of the longest side? Well, this one's 13, this one's 15, and this one would be 17. So it looks like 17 is the longest side. All right, everybody's favorite story problem is about trains. You know, if train A leaves at noon from San Francisco and heads for Chicago going 40 miles per hour, and 2 hours later, train B leaves the same station, also for Chicago, traveling 60 miles an hour, won't train B eventually catch up to train A? And the question is, how long does that take? Okay, so I'm going to set up a little table to help me do these, okay? So let me see here if I can get a little table set up. Okay, that's pretty close. So this is going to be what we call a distance, rate, and time problem, okay? And so I'm going to separate this into kind of like that. So what I know is rate, which is how fast you're going, right? In this case, 40 miles per hour, times time. So big multiplication sign here. This is a time sign. Equals distance. Okay? So now all I have to do is just fill in this table for trains A and B, and then I'll have the information I need to solve the equation, or write the equation. So it says train A leaves at noon, okay, for San Francisco and heads for Chicago going 40 miles per hour. So I know that train A is going 40. Okay. 2 hours later, so we don't really know how long train A travels, do we? Like, do we know train A's time? I know it starts at noon, but we don't know how long it takes, like how long that train is traveling. So I'm going to call it T. Then it says 2 hours later. Well, that tells me time as well. Now, if train A left at T, what time would train B leave? Well, it would be T minus 2 hours. Okay, because train B is going to travel 2 hours less time. It's been sitting. So train A's time is longer. Train B's time is shorter by 2 hours. Okay, now if you want, you could put train A's time as T plus 2 and then put train B's time as just T. That works too. Train B leaves the same station traveling at 60. Now here's what I know. These guys are going to the same place. And I know the distance. I want to know when their distance is equal. When will train B overtake train A? Well, when train B overtakes train A, they'll have traveled to the same spot. Okay? It's just one took less time. So the way I get this column over here is I just multiply like it says up here. So I'm going to take 40 times T, and that gives me 40T. And then I'm going to take 60 times T minus 2. And what I know is I want to know when this distance is equal to this distance. So I'll distribute. I'm going to move the 60T over here since my negative 120 is there. So I'll just subtract 60T. And that gives me negative 20T equals negative 120. And if I divide by negative 20, T equals 6. So how long until train B overtakes train A? Well, the answer is T minus 2. So T minus 2, which T is 6, so 6 minus 2 means my time is 4 hours. Okay. So train A traveled 6 hours. train B traveled 2 hours less than that, so 4 hours. That's when train B overtakes train A. Let's think about that. I guess that's arbitrary. We could say, because it doesn't say how long from what time. It would be better had this said maybe what time does. What time does. I'm sorry. Let me fix this. So instead of how long until, we're just going to scratch that and we're going to put what time does train B overtake train A? Well, right here, train A left at noon and he traveled for 6 hours. And so that means at 6 o'clock, train B overtakes train A. Okay? It's just train B didn't leave until 2 o'clock, right? Because he sat on the tracks there for a couple hours. All right. So here's here's just some information about rate and time and distance questions. So the table can be used to organize your data. All right. So typically we know either the rate or the time. The other is given in mathematical terms. So, like they'll give you the rates and then we've got to use T to represent time. Or we'll give you the times and you have to use R to represent the rates. And then the distance column, you will always multiply the rate and the time columns to get the distance column, okay? So that's why we got that formula, the rate times time equals distance. So this is kind of how you always start with this table. So the equations each involve the distance. So motion in the same directions means distance A will at some point equal distance B if they're going to the same place. If they're going in opposite directions, we're going to add their two distances and set it equal to some total distance. And then if it's a round trip problem, well, the distance there and the distance back are equal. So sometimes it's about one vehicle making a trip to a location and coming back. And in that case, the distances are equal. So this just tells you how to set up your equation each time. So motion in the same direction, you're setting the distances equal. Motion in opposite directions, you're adding the distance and setting it equal to a total distance that the problem's going to give you. And then round trip is distance A equals distance B. Okay? So let's see how these work. So an airplane flew round trip from Indianapolis to Dubai. The plane flew at a speed of 550 miles there and 500 miles back. So I call this a there and back question. Okay? They're going there and they're coming back. The trip home took 1.5 hours more than the trip there. How far away is Dubai from Indianapolis? So the plane flew at a speed of 550 miles there, so that's going to go here as rate. And flying 500 miles on the way back, because if you go west, you're flying into the wind, so there's no tailwind to help you fly faster. It actually fights you, right? The trip home, that means back, took 1.5 hours more than the trip there. So we'll say the trip there took T hours, then the trip home took 1.5 hours more, so T plus or more. Okay, 1.5 hours plus T then. And then the last column you're always going to get by multiplying. 550 times T is 550T, and then 500 times T plus 1.5. Okay? Now your equation then, this is a there and back, so what's true about the distances if I'm going there and coming back? Well, they're going to be the same, so I'm going to write 550 T equals 500 T plus 1.5. And I'm going to distribute. I'll subtract 500t from 550t. That's going to give me 50. And then I'll divide 750 by 50. And then t equals 15 hours. So what do they want? How far away is Dubai from Indy? Well, that's distance. They want the distance. So I have to do one of these two equations right here. I've got to take one of these two expressions and plug 15 hours in. So I'm going to do 550 times 15 hours. And that's 8,250 miles. You know, Dubai's over the Middle East. It's a long way away, halfway around the world. So yeah, that makes sense, doesn't it? Okay. Example 2, Joey and Natasha start from the same point and walk in opposite directions. So this time I've got opposite directions. So I've got Joey and Natasha. Okay, Joey walks 2 kilometers faster than Natasha. So whatever her rate is, he is +2. So she walks R, he walks faster, so he gets the +2 to make his rate faster, okay? After 3 hours, okay, well, they started at the same time, right? And they both walked 3 hours. They are 30 kilometers apart. That means that these two distances are going to equal 30 when we add them together. So opposite direction, we add the two distances, right? So we're going to take D1 plus D2, and that's going to equal this 30. So let's fill in the distance column by multiplying again like we do. So 3 times R plus 2, and this is just 3R. So 3 times R plus 2 plus 3R, that's going to make 3R plus 6. If I distribute, 3R and 3R makes 6R plus 6. Subtract 6, and I get 24. Divide by 6, and I get 4. So how fast did each walk? Well, Natasha walked 4 kilometers per hour. That's Natasha. Then Joey, he walked 6 kilometers per hour. Okay? Just add 2. His rate plus her rate plus 2. Okay? So there's our 2 answers. Always go back and answer the question, right? Example 3, Terry leaves his house riding a bike at 20. Sally leaves 6 hours later on a scooter to catch up with him, traveling at 80. How long will it take her to catch up with him? So we're talking about Terry and Sally. What are their rates? Well, Terry's is 20. And Sally's is 6. No, that's not what it says. She's traveling 80. There we go. Here's the good question to ask you. Who needed more time? Who rode for a longer period of time? So we know their times aren't equal. So I'll just put T's in there. But I know those aren't equal. So somebody's got to get 6 hours more. So did Sally travel 6 more hours, or did Terry travel 6 more hours? Well, Terry traveled longer. He left first. So we're going to add 6 to Terry's because he traveled a longer period of time. So now 20 times T plus 6, 80 times T. How long will it take her to catch up with him? Well, when she catches up with him, their distances will be the same. Their distances will be equal. So 20 times T plus 6 equals 80T. Distribute. Subtract 20 T from 80T. divide. And it's going to take her 2 hours. How long will it take her to catch up with him? 2 hours. Okay. All right, you try. Stop the video, give it a try. At least fill out the table. You know, see if you can get that. And if you get that, try and write the equation. I know if you write the equation, you can solve it. So give this one a try. Okay. So Nick and Chloe. That's my granddaughter's name, Chloe. Left their campsite by a canoe and paddled downstream at an average speed of 12. They turned around and paddled upstream. Well, this isn't a Nick and a Chloe. This is they went downstream and they went upstream. So downstream, they must have gone a lot faster downstream because the current was carrying them along. And then upstream, probably slower because they're fighting the current. It says the total trip took 1 hour. Okay. After how much time did the campers turn around downstream? So if the time downstream was t, the time upstream would be 1 minus t because they had an hour total. So we could just subtract how much time it took to go downstream from 1, and that would give how much time it took to go upstream. Okay? So we have 12t. We have 4 times 1 minus t. And we know that downstream and upstream, they went the same distance. So 12t equals 4 times 1 minus t. Distribute. And then add 4t to 12t, and I get 16t. And divide by 16. And t is 1/4 hour. So then that's downstream. And so after how much time did the campers turn around downstream? Well, 1/4 hour downstream. And then it took 3/4 hour to get back upstream. In other words, 15 minutes downstream and then 45 minutes back upstream, right? Okay. 2 automobiles are 276 kilometers apart. Well, it sounds like motion in opposite directions then. So we know that the total distance is 276. And they travel toward each other at the same time. So we know that their time is just t. Oh, 6 hours. They travel for 6 hours. So we have vehicle A and vehicle B. Well, how fast did vehicle A go? Oh, they travel at rates differing by 5 kilometers per hour. So one of them went R and one went R plus 5, for example. There we go. I think we filled everything in, right? So the 276 is the total. So this is 6R, and this is 6 times R plus 5. So I have 6R plus 6R plus 5 equals 276. I'll distribute. Plus 6R plus 30. And then 6R and 6R make 12R plus 30. Subtract 30. And then divide. I get 20.5. So R is 20.5. So find the rate of each. So one car traveled at, so car A traveled at 20.5 kilometers per hour, and then B traveled at 5 more than that, or 25.5 kilometers per hour. Okay? there's one more. Nope, that's it. So there's a form, 3.5 applications part 2, same thing. You can fill it out, submit it. You'll get results back in your email. It'll tell you which ones you missed. You can go back in, edit your responses, and try and get those correct.